Hi everyone, thank you for joining in this video series. Today we are going to do question 3 of the Mathematics Paper 1, 2022. Now, I hope my mic is much better than the previous videos. So, without further ado, let's begin. So 3.1 gives us the geometric sequence. We know the geometric sequence is equal to Tn A multiplied by R to the power n minus 1. This equation is given in the information sheet. Right? We also have the summation formula and we have the convergence formula. Now we know the first term is equal to 1024. The value of R is equal to Tn all over Tn minus 1. So it can be your second term all over your first term, or your third term all over the second term. It does not matter. So let's find out the value of R, and that should equal to a quarter. Alright. So now we are ready with 3.1.1. Tn is equal to 1024 open brackets 1 over 4 to the power n minus 1. They want the 10th term of the sequence. All we have to do is substitute in 10. And let me put that into the calculator. And we end up with 1 over 256. Let's move on to 3.1.2. This question catches many students, and I'll show you why. It simply has to do with where they want us to take the summation from. And it's also the form in which they've got the geometric sequence. We know the summation equation from the information sheet is given right there. I'll just paste that here. Sn is equal to A open brackets R to the n minus 1 close brackets all over R minus 1. This is only valid for R not equal to 1 and n greater than equal to 1. So if I put in 8 or 9 or 10, this summation will only run from 1 to 8 or to 9 or to 10. It does not run from 0. So let's continue with this part of the expression. That is not in the standard form. We need to write it into its standard form. So Tp is equal to 256 multiplied by 4 to the power 1 minus p. Now the exponent can be rewritten as minus 1 open brackets p plus, I think that would be p minus 1. And that is the exact same thing. So we're just trying to approach standard form. Now we see that 4 is to the power minus 1 multiplied by p minus 1, which is equal to 256 dot open brackets a quarter to the power p minus 1. all this is 4 to the minus 1. But now we have it in a form that is the same as your geometric sequence. So Tn equals to AR to the n minus 1. Exactly the same. The only thing is they want to be fancy and use P instead. I don't know why. I think they want to catch you out. That's why. So A is equal to 256. R is equal to 1 over 4. And now we can use the summation equation. S8 is equal to 256, open brackets, a quarter. I'm going to write 0.25. It's the same thing. All over a quarter minus 1. And that should equal to, let's see, put that into a calculator. That is equal to 341.33. Now this is only the summation from 1 to 8. We need the value at 0. So T subscript 0, 256.1 over 4 to the power 0 minus 1, and that is 1024. So you can see how they catch us here. If we didn't standardize this equation, if we did not standardize this, we would just put in R as 4, and that will give us a completely different solution. Imagine having 4 here. That will give us a different solution. So that is why we have to standardize first and then use your summation formula. We also have to remember that it's only valid at these conditions, from 1 to any number ahead of it. And we had to calculate the 0th term. So now we need to add 1024 plus 341.33, and that is equal to, put that into your calculator, 1365.33. Just to reiterate, this is from 1 to 8, and this is your 0th term, and together they run from 0 to 8, and that is your answer. So for 4 marks it was quite involved. Now we're going to something more fancy. You can notice the transition between question 1, question 2, question 3. It just keeps on getting even more fancy. Don't know why it's blurry now. Okay, there's it. 3.2 gives us the first 2 terms of a geometric sequence. Immediately we know this nonsense. Tn equals to a dot r to the n minus 1. Right? Determine the values of t for which the sequence will converge. We go to our information sheet. We have the convergence formula to infinity, and we have its bounds. So the series converges when between minus 1 to 1, right? But they don't want to know about r, they want to know about t. So we know that r is equal to the current term all over the preceding term. In this case, it is t2 all over t1. Let's write that big expression out. T3 plus 9t squared plus 27t plus 27 divided by 2 all over minus t squared minus 6t minus 9. Now I am uncomfortable with the appearance of this equation simply because of the minus signs, right? So we're going to factor out the minus signs, and we're also going to move the 2 to the denominator. So let's rewrite that. And there you have it. Now that's supposed to be positive, right? Now we need to work with the numerator. The numerator needs to be in a form that will allow us to simplify this expression. And how I approach these questions is looking at the first term and the last term to begin. So we need two terms. When multiplied would give us 27. We can go 27 times 1, but I don't feel it will give us these terms in the middle. It'll be too simple. I think the best bet is 9 and 3, right? So let's expand on that here. T plus 3 open brackets t squared plus 9. I'm using positive terms because you can see all the terms here are positive. Unlikely something is going to be negative, but if it is, we'll pick that up immediately. So you're wondering, why did I put the 3 in this position and the 9 there? It's from looking at the holistic picture. We see the denominator. It begins with t squared, ends with a 9. Here we want the same thing. We want it to begin with the t squared, end with a 9. And that's it. Now we need to find the middle term, your bx term, or your bt in this case. Again, we're just assuming it's going to be positive because all of them are positive on the numerator there. Now we need to find the value here. What can it be? We will do this now. I approach this by multiplying it out. So t times t squared is t cubed. T times plus 9 is positive 9t. 3 times t squared is plus 3t squared. 3 times 9 is plus 27. So we see we have t cubed and 27, exactly like the first equation. The first time we saw this expression. The only thing lacking is instead of 9t we have 27t, and instead of 3t we have 9t squared. So we still have an amount missing. In this case it's 18, in this case it's 6. Now in order to get these missing terms, so 3 times something should give us 60. Hold on. Sorry, 3 times something t will give us 18t, and that value will be 6. Also, t multiplied by 6t will give us 6t squared. We have that there. Now, we can solve this immediately with the calculator, but I just wanted to show you the trial and error process, or solution to do it manually. And now we can see these terms are equal and they cancel off. So we're left with t plus 3 all over minus 2. And now we can substitute this into our convergence expression. Let's do that now. So from minus 1 t plus 3 all over minus 2, from here it's very simple. Multiply everything out by minus 2, we're left with 2 there, t plus 3 minus 2. Then we take the 3 to the other side, change the sign. So 2 minus 3 t minus 2 minus 3. Right. Now this is not the form we want to be in because we're running from minus 1 to minus 5. It's always smallest to biggest. Here we're running from big to small, which is incorrect. If we just draw the number line quickly, minus 5, minus 4, minus 3, minus 2, minus 1. So we want to go from smallest to biggest, left to right. So we need to swap these terms around and write it in a form that's correct. So t from minus 5 to minus 1. And that is your 5 marks. Right, in the next video we will work through question 5. That is, question 4. That's some exponential stuff. Okay, but the important thing here is question 3.1.2. That really needed some manipulation and understanding of the concept. Right? And also question 3.2 just needed some grade 10 maths to simplify this expression. And that was it. The clue when approaching these questions is we know that something has to cancel. So when we factorize this, we are going to get something similar to the first term. So all of this simplification was a bit overboard. We could have used the calculation. We could have used the calculator and used intuition that we will eventually get something like that. Okay, see you in the next one.